Let's figure out the ratio test. Solution, ratio test. Reminding you last time, ratio test checks the limit. So L equals the limit of the ratio, the next term, over the previous term. And it's better be less than 1. If it's greater than 1, it diverges. If it's less than 1, converges absolutely. And we don't really ask you anymore, converges to what? We just want to see if it converges or not. Equal sign, make sure you have enough space. That will take some space. So absolute value takes care of the negative signs, if there are any. And now everywhere, last time I will mention this, everywhere I see n, I will plug n plus 1. Copy, paste. So let me color code it. N plus 1. I would already write down n plus 7 right away, but okay. N plus 1, or again, n plus 7 total factorial over e n plus 1 minus 8, n plus 1 minus 8. If you watch my older video about ratio test, you will actually hear me really well saying that these amazing factorials will simplify. I actually did listen to it, and I never noticed until someone pointed this out. It's upsetting. And now when I was watching those videos in the headphones, you can feel the pain. Now I do notice now when people actually point it out. You should go check it out. It's actually very funny. I forgot limit, and goes to infinity. But again, that's how we say it in my language, okay? So anyway, just imagine I was saying it in different language. That's not the end. Multiply by the original series, but you flip it because we're multiplying by the reciprocal. That's the official term in English. Very fast, done. This is how big it looks like. Now your job is to collect the terms that look alike and then start simplifying everything you can. Let's figure this out. Let's collect square roots on top of each other. The square root at the top is n plus 7. The square root at the bottom is n plus 6. Agree? I will make some mistakes on purpose, so you better pay attention. N plus 7 factorial over n plus 6 factorial. Agree? Finally, en minus 8 all over en minus 7. I think everything is correct here. Factorials are, so this is the first one when we changed, and this is the second one when we didn't change. Yeah? Yeah, here it is. Yeah, factorial, square root, then factorial, then over exponential. That's why I want to show this example, because it has 3 types of functions. Okay, now start simplifying everything you can. Don't touch the square roots. We cannot cancel them out. Remember that. We just keep them as it is. That will be part of the limit to figure out. N plus 7 over square root of n plus 6. But what we can figure out is the other two guys. So n plus 7 factorial over n plus 6 factorial. Can we figure out anything or just no? What do you think? It's n plus 7 over 1. Exactly. Let's maybe one more time show you why last time. 1 times 2 times 3, blah, blah, blah. N plus 6, n plus 7. That's the definition of the factorial n plus 7 factorial. 1 times 2 times 3, blah, blah, blah. N plus 6, and it stopped. Since all of these are products, not sums or differences, you can cancel out the products, and the tail stays, wherever it was. So the one that has a larger number will stay as a tail. Well, I don't know. That's a not professional way to explain it, but I like it. Times e to what power? Let me show you one. Yes, I heard you. Thank you. N plus 8 minus n minus 7. That's properties of exponents. The top minus the bottom you subtract. Finally, the result before we work with limits will be, don't touch the square roots, n plus 7 and n plus 6. just write down n plus 7 times e. So n cancels that with n. Minus 8 plus 7 is minus 1. Thank you. Which is a number. So let's see what is not a number here. Everywhere you see n, that will go to infinity. Only e to the minus 1, which is 1 over e, is not part of the limit, so it doesn't move. So you can kick it out. Your job is now to figure out where all this amazing stuff is going. What do you think? Where does it go? Let's check slowly. This piece goes to what? 1. Because you find the leader of the top. The leader of the top is square root of n. The leader of the bottom is square root of n. Numbers don't change the limit. It goes to infinity, okay? Infinity plus a number is still infinity. So since they have the same speed, the answer will be the ratio of the leading coefficient, which is 1. This guy goes to what? Infinity. So infinity times e or any other number is infinity. Or you can see that the top fraction will have n to the higher power. 1 plus 1/2, 3/2, right? Over 1/2. So the numerator explodes faster than denominator. That gives you infinity. What does this mean? Greater than 1. That's the most important answer. Since L is greater than 1, I don't even care if it's infinity or not. I keep repeating this phrase a lot because that's important. I don't care what is happening with this number. What I care is it is greater than 1 because it's a test. It just tests the ratios. Then this series diverges. Absolutely. Not O. No, it just diverges. Blows up. If it converges, converges absolutely, but it's just diverges. This is your homework problem. Can you do that? So most of them are just like annoyingly tedious with algebra, but the idea is exactly the same all the time. So I have a question for you. What if we did a divergence test right away? Do you think it would show us it blows up or not? Note, for some problems you can actually do that. Let's check. Note with E. What if we check the divergence test? Divergence test. Because we know the divergence test should tell us when stuff diverges. So let me go to the original function. The original function is this one. And let's check what is happening at infinity. Limit of the original function, the square root of n plus 6 factorial over e to the, I forgot, n plus 6? No. n minus 8, thank you. N minus 8. N goes to infinity. Okay, it may be not very clear, is it actually not 0 or not? But I mentioned last times that if you check speeds of functions, and I do have video on that, speeds of functions, I do have video, I teach it in Calculus 1 as well. And when we work with limits, that video is really good. Then the log is the slowest one, okay, at infinity. That's important, at infinity. Then we have linear, like x plus 1. It's faster than log. Then we have quadratic, like x squared minus 5. Then we have exponential, a to the x, 17 to the x. And then we have n factorial. So, because of knowing this, seeing factorial to be in the numerator, intuition tells us that actually probably it will blow up. It probably is not 0. So I assume right away that is infinity, which is not 0, diverges by divergence tests. But to be honest, not very clear, because then we multiply. Actually, no, it is very clear. This function, which is n plus 6 factorial, is already faster than e to the n minus 6. But then it also multiplied by square root of n. For sure, the numerator blows up. So diverges by divergence test. Diverges by the divergence test. So we actually kind of spent too much time simplifying all of this. We could just check the speed. We could just check the tails. Tails must go to 0. Tails must go to 0 for the series not to diverge. It might still diverge, but at least we know it should be 0. If it's not 0, for sure we know it diverges. So for you to know, there's a function that's faster than e to the x and n factorial. This function is x to the x. That's both exponential and polynomial. It doesn't have a name. We did teach it to you, but you don't remember. Do you remember logarithmic differentiation in Calculus 1? There's a whole chapter about it. When we ask you to differentiate this function, there's only one way to do it, to use logarithmic differentiation. So it's like off topic. You put log on the both sides, ln y equals ln x to the x goes down, blah, 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 you have product rule, and then you find the speed of that function. And the speed of that function is fast, super fast. So now you know this is like a nice review of the speeds of functions. Let me put it in the rainbow box. And I show you this with the graphs in my video. Yes? But it's stronger than exponential growth, because if you think about it, e to the x, that's exponential growth, but e is a fixed number. Now x is a variable, and x is a variable. So the base is exploding to infinity, and the exponent is exploding to infinity. They both grow like crazy. That's why it's so interesting. So this function doesn't have a name. It's neither exponential nor the polynomial. Does that make sense? Why did I do the divergence test? And then to show you more, let me show you this one. How about this is also homework problem, and we can move on. Example, how about this one? Sum 6 to the n 4n squared. N is from 5 to infinity. Someone asked last time, doesn't matter if it's from 5, minus 11, and stuff. Ratio test, ratio test. We're checking in the long run, so it doesn't matter where it starts, most of the time. Should I perform ratio test or not? Nah, too much time wasted. Don't you see that the divergence test will tell you the answer? See, divergence test is a good helper if you can have intuition when stuff blows up. If it doesn't blow up right away, then you perform some kind of test. Ratio test, integral test, we should show you, and maybe it is geometric series, blah, blah, blah. But divergence test will work even in the upper level chapters. Divergence test tells you, well, if I check the tails of this function, I notice that the bottom is a polynomial. Polynomial, so maybe here I should tell you, it's not just quadratic, just polynomial. So x to the 7, plus 11, those kind of things. Just polynomial. Polynomial is slower than exponential function. So the top blows up faster to infinity than the bottom. Not 0. Diverges by divergence test. Diverges by divergence test. That's one of your homeworks. Yes, you can still perform ratio test, and you will see it supports this idea. Ratio test will tell you L is some kind of number greater than 1, and that means diverges by the ratio test as well. Those are just tests. Choose the simplest test to move on. That's your homework problem as well. Isn't it cool? So I want you to be smart. Don't just use the ratio test because it's a chapter about ratio test. You have some previous knowledge. You can use it to speed yourself up. On a test, same thing. I'll give you a function, you're like, oh, it looks like ratio test. No, just check the tails first. Check that tails indeed do go to 0. That's what I call them. The tails, because it's n at infinity, right? And they don't, so diverges. By divergence test. What do you think about this? Make sense? Not too bad.